Hello and welcome to Lesson 1-4, Angle Pair Relationships. In geometry, there are a series of angle relationships that are really important. We're going to look at the first set of those today. Our first one is adjacent angles, and the word adjacent simply means next to. So, for example, if I say park adjacent to the bike rack, you would park next to the bike rack. So if I tell you that angle 1 and angle 4 are adjacent angles, that means that they are angles that are next to each other. Now, they always have a common vertex and have exactly one common side array, right? Yeah, side, hello. There are no common interior points, though. So, for example, if I had this angle and then I drew an angle inside of it, they are not, this angle and this angle are not adjacent to each other because they share too much, basically. They have common points, common interior points. So those are not adjacent angles. If two angles are adjacent, we can't say anything about their respective angle measures. This is more clearly seen in the diagram below, where I've added in a few more angles to make it a little bit more complicated. Right now, I want you on your own to pause the video and list all of the pairs of adjacent angles you can find in the diagram below. So this is a trimeme. List all those adjacent angles. Another very significant type of angle pair relationship are vertical angles. Vertical angles are formed by two intersecting lines. So in the diagram directly above, angle 1 and angle 4 are vertical angles because they're formed by two lines intersecting. So when this line intersects this line, they form two angles. Angle 1 and angle 4, those are my vertical angles. Angle 5 and angle 2 are not vertical angles because while they share one side, this side right here, they don't share the second side. Angle 5 is made of this segment here, and angle 2 is this segment here. They're separate segments. So they're not formed by intersecting lines. The definition of a vertical angle, we say that two angles are vertical angles if and only if their sides together form intersecting lines. This has a different meaning to the word vertical. It has nothing to do with up and down. So while yes, these two angles happen to be vertical angles, they are up and down, angle AED, this guy, and angle BEC, this guy, are also vertical angles. So anytime I draw just two segments, lines, rays, whatever, crossing, we are automatically going to form two pairs of vertical angles. Now, once I start adding more to that, of course, that's no longer true, but just so you can see, that's what's going on. I want you now, as a trimeme, to list, so actually write out the names of my pairs of vertical angles in the diagram above. My next type of special angle relationship is a linear pair. So let's look at this. Angles AOB and BOC form a linear pair if and only if AOB and BOC are adjacent and AOC is a straight angle. So I asked to draw the diagram for this statement. Well, let's take a look at it. So we have to have two adjacent angles, that means two angles that are next to each other, and AOC has to be a straight angle. Well, a straight angle is simply a line. And on that line, I have to have points A, O, C in that order for that to properly name the angle. Now I have two angles AOB and BOC. Well, they both share point B, so I have to have another ray coming off here with a point B right there. So now let's double check and make sure our diagram matches what's written. AOB and BOC form a linear pair if and only if AOB and BOC are adjacent. Well, that's true. They're adjacent to each other. And AOC is a straight angle. That's also true. All right. So looking at my diagram now below, angles 1 and 5 are a linear pair, cancel. Angles 1 and 5 are a linear pair because they satisfy that. If we look at 1 and 5 together, they form this straight angle here, and they're adjacent. Therefore, we know that the measure of angle 5 plus the measure of angle 1 must equal 180 degrees because the measurement of every straight angle is 180 degrees. So we can also say that angle 5 and angle 1 are supplementary. Angles 1, 2, and 3, on the other hand, are in fact not straight angles because there are 3 angles. Are not a linear pair because there are 3 angles. In order to be a linear pair, you have to have a pair of angles. So if you have more than 2 angles forming a line or a straight angle, then it's not a linear pair. While 1, 2, and 3 are not a linear pair, their measures will still sum to 180, but they are definitely not a linear pair. So now I want you on your own, for your try me, what is the other linear pair in the diagram above? Right, and just as a very quick review, in middle school, you learned about complementary and supplementary angles, but just to get that thought back in your head, let's take a look at them. Complementary angles are angle pairs whose measures sum to 90. They don't have to be adjacent, they don't have to share a vertex to be complementary. All they have to do is sum to 90. So for example, over here, these 2 angles, when I add those together, that sums to 90 degrees. So even though they're not even they're not even within the same figure, so to speak, they're still complementary. Angle 1 and angle 2 are also complementary, and they are adjacent. So being adjacent and being complementary are not mutually exclusive events, but nor do they rely on each other. So supplementary is very similar. 2 angles are supplementary if and only if their angle measures are 180 degrees. Looking at my first one, angles 7 and 6 are a linear pair and they form a straight angle. Therefore, we dropped an M. There should be an M right there, folks. The measure of angle 7 plus the measure of angle 6 equals 180. So 7 and 6 are also supplementary. So you can conclude that all linear pairs are supplementary. I'm running out of space. Okay. However, I can still have supplementary angles that are not linear pairs. Here, these 2 angles definitely don't touch, so they're not a linear pair. So, not a linear pair. But they are still supplementary. So, all linear pairs are supplementary, but not all supplementary angles are linear pairs. I believe that's the end of the notes, guys. Thank you very much. Be sure to go back and do the try me's if you haven't already and move on to your homework. Thank you.